Hello everyone. So today we will be solving an interesting problem from IOAA 2024. It's a theory question number 4. It's based on white dwarf. So the question says that the structure of a white dwarf is sustained against a gravitational collapse by the pressure of degenerate electrons, a phenomenon explained by quantum physics and related to Pauli exclusion principle for electrons. The equation of a state of a gas made of a non-relativistic degenerate electron is following. So I have been given a state of a gas, that is P equals to 3 8 pi uh, 2 by 3 and h square 5 me ne 5 by 3, where my ne is given by number of electron per unit volume, that is number density of electron, number of electron per unit volume. And then it also says that which the ne can be expressed in term of mass density using the dimensionless factor mu e, the number of nucleon uh, per unit electron. That is my mu e has been given to us. Mu e has been given to us, which is number of nucleon, that is a, divided by per unit electron, that is I need to divide it by z. So where my uh, is number of nucleon and then number of electron. And also it is said that the central pressure can be described by this equation of the state. Okay, before starting the next portion of a question, I want to say that uh, this pressure this pressure is derived from statistical mechanics, which is beyond the scope of high school students. So this is from a pure statistical mechanics method. And then mu e is what we mu e is called. It is also called as uh, mean molecular weight mean molecular weight per unit electron. This is defined as a mean molecular weight as well. So these all are the result from statistical mechanics. So if I look into the next portion, it says that in the condition of hydrostatic equilibrium, the pressure and gravitational force balance each other at any distance r from the center of the star. This condition can be expressed by this equation for a hydrostatic equilibrium. So I have been given another set of equation. It is dp by dr uh, minus g m by r rho r by r square, where my mr is mass contained in a sphere of radius r. It's a mass in sphere of radius r, sphere of radius r, and my rho r is at mass density. Rho r is my mass density. This mass density. So now assume that mp equals to mn. So that is my both nucleon mass are same, comparatively same, and my density of a white dwarf is roughly uniform. The following approximation is valid at the surface of star. So when I look into the surface of star, uh, at surface of star I have been given a boundary condition. It's a condition that has been provided that my dp by dr at r equals to r equals is equal to, also it's approximately minus pc by r. This has been told, where my pc is pressure at the center. So pc is pressure at center. This has been provided. So now My first question is that I need to find the relationship between the mass and the radius of white dwarf is defined as r equals to a dot mb. So we also know that for part 1 we have a relation r equals to a mb, where uh, find the exponent b and determine the coefficient a in terms of physical constant and mu e. So now my question is asking me to find a and b. Okay, right. Now, if you look into the question, we have been provided my uh, hydrostatic equilibrium equation, which is dp by dr equals to minus gm r by rho r. That has been provided, and also a condition has been provided that at r equals to r, it's minus rho c by r. Sorry, pc by r. So now, if I look into this, if I say my dp by dr equals to minus gmr rho r by r square, if r equals to r, my this equation 1, if I assume this equation 1 can be written as dp by dr equals to minus gm r, this is rho, and then r square, right? And rho r. Okay, let us assume we can consider mrbm and rho rb rho. It's just that total mass and total density I'm considering it, right? So dp by dr uh, equals to minus gm by r, sorry, gm rho by r square. I get equation 2. Now when I solve my hydrostatic equilibrium, I'm getting this, but we have been said that we get this equation for this equation for uh, at this relation is valid according to the question. So what we can write? We can write minus gm rho by r square equals to minus r, which implies that this c equals to, yeah, it's this cancel out, minus minus cancel out, it's gm rho by r. This is my third equation. So now we get the value of my pressure at the center. When you look into the question, it is said that this equation can be used to describe the pressure at the central. So here we can see central pressure can be described by this equation instead, right? So now uh, according to question, according to question, central pressure can be described by P equals to 3 8 pi 2 by 3 h square by 5 me ne 5 by 3. So that is PC can be written by 3 8 pi 2 by 3 h square 5 me ne 5 by 3. So now I can equate this is supposed to be equation number 4. Now if I can equate equation 3 and equation 4, uh, now equating equation 3 and 4, we can write that gm rho by r is equal to 3 8 pi 2 by 3 h square 5 me ne 1 by 3. Okay, so this is the equation that we are getting. Now if I look into what was the question that we are asking, we were asked that we need to find the relationship between radius, mass, and then there is one power, and then my a is in term of physical constant. So how do we change those parameters now? If I look into this equation, this g, this is my constant, m I can use, r I can use, but rho I can't use because I need to find the relationship between r and then m, and I only can use, I just need to find rm. So I need to convert this one, right? This is also my constant, this is also my constant, this is also a constant, this is also a constant, and then ne is not a constant because n is a number density. So there are two parameters that we need to change. Rho need to be converted to um, physical parameter that we can use, like constant, or any need to be converted. So for rho we can write mass upon volume, which is total mass divided by 4 by 3 pi r cube. So it's 3m by 4 pi r cube. Thus my LHS become, my LHS can be written as it's gm rho, gm 3m by r 4 pi r cube, which turns out to be 3 gm square by 4 pi r4, right? So now you can see I have a relation where there is only mass, my physical constant, and then my radius. So if I equate this, I will get that value. Now for this ne, I need to consider it, how to change ne. So uh, if I look into the relation, we have been said that mu e is given by a by z, and then my any can be expressed in term of mass density using the dimensionless factor mu e. So what they are saying is any can be considered, any can be expressed in term of mass density rho. So how can you consider a mass density? Uh, we know mu is equal to a by z, that is number of nucleon per unit electron. So mu e times m n, where mn is mass of nucleon. If I do this, what does it give me? So if mu is number of nucleon per unit electron, if I multiply with mass of nucleon, it gives me total mass of nucleon per unit electron. right? So what does this total mass of nucleon means? Total mass of nucleon means it is my total mass, uh, total mass of matter, total mass of matter present uh, per unit electron, per unit electron. So rho can be written as mu e times mn, and if I multiply the number density, which is given by ne, right? So I get this, my total density can be written as mu e mn ne, and we know mn is equal to mp equals to mn. So I am just using my nucleon has been, we have been given this condition according to the question. My mp and mn are same, and it's a uniform density, right? So I can just write that value, and then I can just choose this. Okay, so mm, now I got this equation. So my for RHS, for RHS we can write now P, it's 3 by 8 pi 2 by 3 h square by 5 me, and then ne 5 by 3. It's ne 5 by 3, right? So ne can be considered as rho by mu e mn, and we know rho is equal to 3m by 4 pi r cube. Sorry, it's mp or mn, we can write it anything. So ne can be considered as 3m 4 pi r cube mu e mp, and if I substitute this here, my RHS, total RHS become 3 by 8 pi 2 by 3 h square by 5 me 3m 4 pi r cube mu a mp 5 by 3. Now you look in LHS also. Now in LHS also I am getting a constant m and r. We need to find the relation between m and r, and in RHS also we are getting all those constant. This is constant mr, mu in mp, these are all constant, right? So now if I equate this value, uh, now we can write, so if I get, so if I just can, if I can just substitute this value, if I can just substitute this value, now we'll get some relation which will be for me r in terms of m, right? So now let's substitute those value, solve for r. It will be now 3g m square 4 pi r4 3 8 pi 2 by 3 h square 5 me 3, and then I can substitute 4 pi mu e mp by 5 by 3, and m equals to 5 by 3. right? So 3g 4 pi, uh, it's 1 by r 5 as well, yeah, because this three concept, yeah. So and r4 and r equals to, this is a constant. I can assume this constant as, okay, I can just multiply this here. R can be considered as some constant, which is some constant a we do know, and then m 5 by 3 minus 2. So it's a m 5 by 3 minus 2, it's 1 minus, yeah, right. And where a is equal to 3 8 pi, uh, 2 by 3 h square by 5 me 3 4 pi mu e mp, uh, 5 by 3 multiply by 4 pi, multiply by 4 pi 3g, multiply by 4 pi 3g. So now we got a as well as b, and my a is only in terms of whole constant, and then mu e, what it was asked in my question, right? Yeah, so this has been provided. So and my b is minus 1 by 3. So when the second part of this question asks, using the relationship from previous part, estimate the radius of a white dwarf, um, fully ionized carbon with mass, which is equal to 1 solar mass, right? So for radius, we know we have been provided a m minus 1 by 3, and to a, for calculation of a, we have every constant. H value we do know, me value we know, mp value we know, g value we know. We just need to find mu e. So mu e can be written as a by z. It's for a carbon, it's 12 by 6, it's 2. So my mu is 2, and then uh, if I substitute my value, my if I substitute my value, and my m has been also provided, m is 1 solar mass, and if I substitute my value, I'll just simply get this equation, which approximately turns out to be 1440 kilometer. Yeah, so it's pretty easy to, so it's pretty neat equation. I just also want to emphasize that this is a standard equation for a white dwarf. When we are talking about a white dwarf, we simply say that mu is given by 2, but it's not for all white dwarf, but generally for a fully ionized carbon white dwarf. Yeah, fully ionized carbon. And then when you look into this relation for r and mass, you see that when my mass increases, if my mass increases, my radius decreases. So you can just simply imagine that when my mass increases, my gravitational force increases. Because of that, my star become more compact, more compact, right? So this is the relation, and we can say that because of that electron density increases to handle the equilibrium. So I hope this equation was easy to solve. This is pretty neat equation. Thank you.